need our books today?
Yes.
Alright.
We'll talk about it, because you need your homework. Okay, here's what you need. You need to have your homework out with you, please. Did anyone turn in last week? Page 41, I'm betting not. Perfect, okay. Now, the next thing I need to do, we're gonna just have it out, don't turn in, have it out. We're gonna talk about 9, 10, 39, 40. I'm gonna put them on the board, we're gonna do them, okay? Because I may have told you number 9 wrong, because I read it wrong, and I'll explain why. Okay, all right, so have those out in front of you. Real quick, I gotta do some...
Me and Trevor turned ours in.
Okay, I'll hand those back to you in a second. All right. Ben should be able to turn these on. Okay. Alright. Anyone else not turn in? Or did turn in, I should say. Perfect. Alright. There you go, gentlemen. You can have that back so we can talk about it. Still do 9. 6 if I did. Pop it up on board, we're going to take a look at it. Okay, here's what I recommend. Not that. Right, what I read was... Perfect. Alright, so. Okay, here's what I read wrong, and I don't know if I told you guys this or period 6. I don't know which one, so I just need to make sure we cover it. All right. So what I read was LKN. Well, that's not this. So I read it. So I don't know if it was your guys' class I told it. I thought it said an N here. So LKN is this entire angle right here. That's the big angle. Now what we know from the instructions, if you see this, okay, this part right here, that KN bisects LKN. That's the angle that we're talking about right there. It's that one that I just marked in black. That's LKN. How I know that? L to KN. So it's that entire angle. This thing bisects it. That means it cuts it into perfect halves. That's what bisecting means. Bi is 2, sections is cutting into pieces. So it's cutting into 2 pieces. So that means these 2 angles here and here are exactly the same angle. That's just something you need to get from the instructions. Other things from the instructions, these 2 rays here are opposite, so they go the opposite directions. So it makes a straight line, that's what you should know. So we have a bunch of pieces there we can put together. Now on 9, they give you that LKM, that's this entire angle, this whole thing, is a 7x minus 5. I think I said that wrong. I think last week I said that like this piece is 7x minus 5. And that's what I think I got wrong. Okay, does that make sense? The whole thing is 7x minus 5? Alright, so that's that. Then the other piece that they give you is the 3x plus 9, and that's the NKM. That's this piece is a 3x plus 9. And I think last week I told you all you had to do was set them equal to each other. They're not equal, look at that. Is this tiny angle right here equal to the big one? No, because I read too fast. I thought they needed this piece. So I just said equal. So that's not right. So what you need to do is you need to realize, since this piece here is equal to that one, what can I put in this spot right here? 3x plus 9. Alright, so this is a 3x plus 9. Okay, does everyone see that? Okay, now that we have that label, the 3x plus 9, the 3x plus 9, when you add these 2 pieces together, guess what it makes? That. And that's what you need to put. So if you need to fix number 9, erase it right now. Let's put this stuff in here. So we have 3x plus 9 plus 3x plus 9. And we're going to set that equal to a 7x minus 5. That's what we're going to do. Does that make sense now? Okay. So now that we have that, now what we're going to do is we're going to solve for x, and then we can answer the second question, which is, I believe they want you to find the entire angle. So this is the second part. There's always 2 parts. You have to find x and then go back and plug it in. We'll do number 10 here in a second too. We'll go through that one as well. But does everyone understand the setup, how I labeled it? Alright, let's solve this out. What do I get on this end? Let's combine some like terms. 6x plus 18, okay? Plus 18, because you can add the x's together. 18, 7x minus 5. Alright, now that we have this, now I can start moving things around. I can move the x's, I can move the numbers, and we can solve this thing out. That's just how I think of it. So you're subtracting the 18 from both sides technically, but I'm just going to subtract it over. So it's a negative 5 minus the 18. I'm just going to move it over. At the same time, I'm moving the 7x over because I'm subtracting 7's from both sides. So it's this. That's just how I see it. How I look at it. Okay, what is 6x minus a 7x? Negative 1x. Yeah, you're right. It's an x, but it's a negative. So it's a negative 1x. Yeah. And if you just want to write negative x, that's fine too. The 1 doesn't need to sit there. Okay. Negative 5 minus 18. Negative 23. Now what do I do? Divide by the negatives. So divide by the negative 1, and you get x by itself is equal to 23. Now that's if you did it like me. I know this seems very odd. I don't know why, just as a personal preference with me, I always move the variables to the left side, the numbers to the right side. It's a personal preference. It really doesn't make a difference. If you brought the 6x over here and you brought the 5 over, it would have been the same answer. You got x is 23. I need to make sure I show you that because some people get stuck in the algebra frame of mind where letters are always on the left and numbers are always on the right. It doesn't want me to. That's how I see it. All right. Any questions so far? We're not done now. We have the x's of 23. The question is, They want to know what the entire angle is. LKM. That is this entire angle. So all I need to do is realize this is the entire angle. That is LKM. So what am I going to do with that 23? Plug it in here. That's what you're going to do. So, because the entire angle is the 7x minus 5. So if I plug the 23 in, it'll give me the angle for it. That's what we're going to do. So 7 times the 23 minus 5. That's what we're going to do. Now 7 times 23, just off to the side. 7 times 23, off to the side. That's a 21, carry a 2. That's a 14 plus 2 is 161. And we're going to subtract 5. And what's 161 minus 5? 156. Okay. And that's probably the answer they have in the back of the book if you check the odds. You're probably wondering, why didn't we get that same answer last week? Because I told you. So, okay. Any questions with that problem? That helped you out? I bet there was a ton of questions on that. I know there was last week. Okay. You need more time to write that down. Again, fix it. If you made a mistake, if that's not the answer you got, put that stuff on your paper. It changes. Okay, let's talk about number 10 now, because I did promise I want to go through 10. Okay, 10 is a little bit different. It's a different type of problem than 9. You just have to piece together what they're giving you, what they're trying to explain, how to label the picture, and then we're going to do the same type of math where we solve and you plug it back in, whatever they need you to find. And that's how we're going to do 39 and 40 as well. Okay, so let's go on to number 10. Let's label. Anyone need that still? Okay, let's go on to 10. So let's label the picture so you can see kind of how I process this, how I look at it. Okay, NKL, that is this angle right here. That's NKL. That angle supposedly is a 7x minus 9. All right, 7x minus 9. All right, and then what else do they give me? They give me a JKM, and that is an x plus 3. Okay, and then they want you to figure out angles. Okay, so a little goofy on this part. Okay, the thing is from the instructions, these instructions earlier have not changed. So, going back to what we talked about earlier, what can you tell me about this angle right here? It's a what? Yeah, it's a 7x minus 9. The reason why, they said these two angles were the same earlier, because KN is the middle of this angle. So that means these two pieces are the same. That's what you just need to realize. You need to piece together what the instructions say. Okay, so now that I have this label, and they also said that these are opposites, that these two sticks are opposites, that means they make a straight line. If that's a straight line here, what do you get when you put all three angles together? Yeah, you get 180 degrees. Literally makes an entire protractor. So that's what I'm going to do. I'm going to add those three angles together, set equal to 180. The reason I'm doing that is because that's the only thing I can do. You don't set these equal to each other. They're not even the same. I don't know that. They don't tell me that from the picture. So all I can do is add the three angles, set it equal to 180. Once I get x, then I can go back and figure out what they want me to find, which I'm going to wait till later. I don't even care what they want me to find right now. I just need to figure out what this adds up to be. So x plus 3 plus the 7x minus 9 plus the 7x minus 9 equals 180 degrees. Okay, because we're doing angle addition, right? You're adding three adjacent angles, it makes an entire straight angle, or a what we call it, kind of a linear pair. It's actually a trio of angles there. Okay, let's solve this thing out. Let's see what we can find. How many x's do I have total here? Yeah, there's 15 x's there, so 15 x's, 1 plus 7 plus 7. 9, negative 3, negative 9, that's negative 18, plus a positive 3, which is a negative 16. Is that right? 18, 15, 15. Cool. Do some more math. All right. And Any questions of how I did that? That was the positive 3, negative 9, negative 9. Okay, now, how am I going to solve? Add the 15 across, just the normal 15, right? You're going to add 15 to both sides, but it's basically just putting it over here. So if I add that 15 across, you're going to get 195 on that side. So I get 15x equals 195. And now what? Divide by 15, right? So I'm going to divide by 15, divide by 15. X equals, let's see, a 1, that's a 4, by 13. Divide by Alright, so that's X. Now that we have X, now we can answer the question that they want you to find. The question is, the second part anyway, is find JKN, that angle, the measure of it. So I need to find the number, JKN. Now let's go to the picture and figure out what JKN is, because I have no idea. JKN. Ooh, okay, so that's this entire angle right here. That's what they want me to find. That's the secondary part. So basically what I need to do is take this 13, plug it in here, and plug it in here to these two parts. And once I have these numbers, then what I can do is I can add them together. So it's kind of a two-parter. So if I plug a 13 in here, what is 13 plus 3? 16. So that's 16 for that angle. Now I'm going to plug a 13 in here. So I'm going to take a 7 times 13, and then I'm going to subtract 9. Now 7 times 13 is 1 here 2, it's 91, and we're going to subtract 9. That's 7 times 13 is 91. And what is 91 minus 9? 82. Is it 82? Right. Okay, there's 82. And now what I can do is I'm going to add these together. Because all I did was plug the 13 into both of them. Because the whole entire angle is what I'm trying to find. So 16 plus 82, if you add these two angles together, you should get 98. And that's the angle that we're going to find. That's that. 156. Okay, any questions on 10? That was definitely hard. I understand that. Okay, do we feel more comfortable with those now? Like how to set those up? Alright, let's flip the page. Let's go to, if you have your book out, let's look at like 39 or 40 or one of the ones around there, because I did promise you I want to go through those. Alright, so let's go through those. Okay, now it's your guys' choice which one you'd like, because I mean these are all roughly the same type of problem like what I just did. We're gonna be using this picture. They have a couple of the things labeled here on this picture where like this angle here is equal to this one, even though they don't look like it, they are the same. And I believe in the instructions they said that BA and BC, these are opposites, so it means this makes a full 180 degrees. And the other thing, this is the big one. This thing bisects this angle. EBC, that's this angle here. This stick, BH, bisects it. That means this angle here and this angle are the same. So that means these two put together make this one. So that's the instructions. That's important, I think, for these later ones, for sure. That these two, this angle here is the same as that one. But it's your guys' choice. So which one of these would you like? I might go through one or two of them. I think we only had to go through 40. So we only had to do these. So don't say 41 or 42. So, okay. Your guys' choice though. Which one would you like? 39? Let's start with that one. Okay. Is there any problems with doing 39? Alright, let's do that. So 39, let's label the picture. Let's try to figure out what they're giving me, what they want. Because I think it's a two-parter again. Alright, 39, they give me ABF is a 7x minus 24. So here's A to B to F. So that's this angle here, it's the entire angle. They're giving me is a 7B minus 24. Okay? So this one, 39. ABE Ooh, that's a smaller one. Alright, so ABE, this thing, just this little angle by itself, right here, this is a 2B. Okay, so let me move the labels here. So that little angle's a 2B. This entire thing is a 7B minus 24. Alright, now, obviously don't just set these equal to each other. They're not, right? That's huge, this one's really small. But what can I do? Yeah, add a 2B with what? Yeah, I can put another 2B right here. Because if you look at the picture, they have a little pink marker. That means these are both 2Bs. They're both the same angle, right? That's what the picture says. That's what it has labeled. So now that I have both of these angles labeled side by side, they add together to make this thing. So 2B plus another 2B should make the entire 7B minus 24. That's what you need to realize. So two of them side by side make the bigger angle. Okay, does everyone understand the setup on that one? I know it's tough when you first look at it. That's why when I do these, I draw the picture and I start labeling all these different answers. That's just how I do it. I look at the picture and I start labeling it. Okay, let's solve this thing out. Let's see if we can solve this thing. So this adds together to make a 4B. It's 7B on this side minus the 24. Okay, now how am I going to solve it? What should I do? Subtract 7B across. Okay. So let's subtract this 7B over. So 4B minus the 7B. Now I can solve that thing out. So that should make a negative 3B on the side. So technically what you're doing is you're subtracting 7 from both sides. I'm going to show you what to do. 3B equals negative 24. And divided by negative 3. So B is a positive 8. So we can get the negative signs would cancel. So positive 8. Now that we know that, now we can answer the question that they want. So let's figure out what the secondary question is here. Find this angle right here. EBF. EBF. Well, if we look at the picture, EBF is that angle. That's EBF. E to B to F. So it's just a 2B. So what am I going to do with that 8? Yeah, you're going to plug it in, right? I'm just going to take that little 8 we just found and plug it in right here, and you're going to take it times 2. It's 2 times 8. That's because B is an 8. So that means your angle here is a 16. 16 degrees. Move on to the next problem. Okay. 39 makes sense to you? If you need to make fixes, please make fixes. This is the time you're getting freebies, because this is the time where you can learn some stuff. You watch me do it, you can see how I'm setting it up, how I'm thinking about it. Okay, any other problems you'd like to go over? Or you just want a little bit of time to finish 40? You want to try it again? Okay, I'll give you 5 minutes or so. Try to finish some problems, maybe you need to make some fixes. Okay? This assignment is due at some point today. I don't care what time. I don't care if you turn in after school today, but it's due at some point today. If you know you're done, or you want to make some fixes at some point, maybe have a study hall, that's fine, you can take it with you, but there you go. Okay, I'll give you 5 minutes here, just to make some quick fixes. Then what we're going to do today, we're going to do a couple examples of this stuff. Okay? Alright, give you 5 minutes here. Freda, and Bailey, try to remind the girls we have the team dinner tonight. I think it was an email. It's after practice, so try to remind them. Okay. Trish, same thing. Trinity, same thing. Okay, try to remind the girls when we go to practice with team dinner. Okay. Plus, I think Stefan's put some stuff in the email and stuff just this morning, so try to check that out. Grades will be updated tonight, so no worries there. So don't be, if you know that you turned an assignment or you did some fixes and it hasn't been put in there, it will be in there tonight. So. Remember, if you're going to make any changes or fixes to any previous assignments, get that in, today or tomorrow, because it's almost a week notice. After that, I don't want to be checking those. So if you got any other previous ones from last week that you want to fix. About another minute here, and then we'll just do a couple notes today, and then that'll be where we finish. Okay. So I just want to talk about kind of what we discussed on Friday, but maybe do a couple more challenging questions with that stuff, because we just did some vocab on Friday. That's all we did. I think the video is already online, so just give you kind of a heads up. We're almost wrapping up chapter 1 here. I think we have like 2 more sections to go after tomorrow, so we'll have sections 6 and 7. We'll try to do 6 and 7 maybe Wednesday, Thursday, Friday, Monday. Maybe that's when we'll finish up section 7. and then we'll be doing our practice test next week, and then that'll be like maybe Tuesday, Wednesday. We do a practice test for 2 days, and then we'll take the test like next Thursday over chapter 1. Does that make sense? I always give it a 2-day practice test for me. Look identical to the test. That's what they are. I mean, it's the same number of questions, same exact layout, same instructions. They look identical. What we do is we go through them like for 2 days, just to make sure that you understand like what the test is going to look like, what I expect you to do. We do them in class, where I just kind of walk through each problem. This is what I'm expecting you to do. This is how you're supposed to do it. You'll have one in your hands, so you can actually work on it at the same time. We'll turn those in the day of the test. It's like your ticket for the test. So here's your practice test. I hit into your test, and then you're off and rolling. All I do is I just switch the problem up. So like on your practice test, I gave you some homework problems. All I did was go to the homework and pick the problem maybe right next to it, and put that one on the test. So that way you know exactly, like, this is the type of problem I want you to solve. Go try it out, and you have your own numbers. So does that make sense? You'll get the practice test probably Thursday this week. That way you have a couple days in advance. You can look it over, get stressed out about it, and we'll look at it next week. So, all right. Let's talk about a couple things today, and then we'll be done. I just want to talk about kind of what you can expect from the stuff we talked about Friday. We just did a couple of vocab words. If you don't remember, we talked about linear pairs. That's where two angles are side by side. They're adjacent to each other. That was one of the key words. These are adjacent angles. Angles that are side by side. They literally are touching. They share that common ray in between them. These are adjacent. They don't have to be the same. I know some of the problems that we just had in that page 41, they had angles that were right next to each other that are equal. This doesn't have to be the case. They're just side by side. Well, what a linear pair is when they're side by side but they make a straight line, like that. That's a linear pair. Okay, so when you add these two angles together, whatever they are, it would add to be 180. Okay, so those are adjacent, linear pair. That was one of the words we talked about. Then we also talked about the word supplementary. And this is one of the words I want to talk about today. This is one that I want to make sure that we understand. Supplementary just means you add two angles together and they make 180. So a linear pair is common sense. That you add the two angles, whatever they are, and you make 180 degrees. Okay, they could be decimals, it could be anything. So it could be a situation like this, where this is a 6x, this is a 5x plus 3, and we can actually solve this thing out. Okay, where you can actually figure out what it is. And again, the pictures don't have to be drawn to scale. They just give you a picture like this, and they'll ask you to solve. Well, and maybe they say that these are opposites. So it's a linear pair, it's straight across. So you would add them together like this. 5x plus 3 would equal 180. Or maybe they say that the two angles are supplementary with each other, which means they add it to 180. So this makes 11x plus 3 equals 180. Subtract 3 across. So you get 11x equals, let's see if I subtract 3, what is that? 177? Maybe we'll do 4. Can I do 4? Maybe that makes it a little bit prettier. Yeah, let's do 4. I'll make it a little bit prettier. So the reason why I do that is because I know that number is divisible by 11. Alright, so we get to this, we divide by 11, and it should work out. That turns out to be a 1 and a 6, so it's 16 if you divide. Okay, and then what can I do with the 16 then? Yeah, you can plug it back in. Right, you can take the 16 here, that's what we just found for x. You can plug it into each of these, and you could figure out what each of these angles are. That's the idea. Okay, that's if they said you had a linear pair or they're supplementary. Now, the reason why I'm bringing this back up is that supplementary doesn't mean that they have to be a linear pair. That's I know that seems weird because I saw a couple pictures in the book where they had just angles kind of free floating, like this. Where this is 120 and this is 60. They had their own labels on them, A, B, C, and X, Y, and Z. when you add up the two numbers, the two angles, like the 60 and 120, what does that make? 180. That's still considered supplementary. I know that seems weird. They're not linear pair though. Linear pairs when they're adjacent, they're right next to each other. This is traditionally how you do angle addition. You can add the two angles together, set equal to something. This still fits the definition of supplementary though. That two numbers add together to make 180. That's all that really the definition of supplementary is. They add to make 180. Even though they're not even close to each other, I know it seems weird, it still works. So that's just something I wanted you to realize. I didn't stress that last week. Okay, are we good with the word supplementary though? They add to make 180? Okay, let's talk about the word complementary. Same exact concept. We could have adjacent angles again, but now here's the difference. This is complementary. Okay, so let's see, A, B, C, D, E, F, G. All right. What do these two combine to make? 90. That's complementary. They add to make 90. Now these just happen to be adjacent, so that's perfect. Whatever these are, let's say this is a 4x and this is a 2x plus 6, let's say. So you could still do that thing like I just did over there where, you know, they make 90 because the little symbol here tells you that they're 90. So 4x plus the 2x plus 6 equals 90. Notice I didn't set them equal to each other. I don't know that the two angles are equal. I just know that they add to make 90. I know some people look and go, well, aren't they 45s? They could be, or it could be like 60 and 30, or 20 and 70. I don't know what the angles are. They just added to make 90. That's all I know. So when I add these together, that's a 6x plus 6 equals 90. Subtracting that over, I might have to make an adjustment here. What is that? 84. Let's see. That's divisible by 3. It is divisible by 2. Yeah, so this will work. That will be divisible by 6. So I divide the 6 over, and let's see. Yeah, when you divide by 6, that's a 1, 2. That's a 14. Okay. Any questions with that? Okay, so, and then what I could do is I could take the 14, plug it back in, and I can figure out each of those angles are separately. If I plug the 14 back up there, and it's a 56. If I did that right, if I plug the 14 in. If I plug the 14 in down here, you'd get 14 times 2, that's 28 plus 6. 28 plus 6, what is that? 34. But yeah, still works. It still gives you 90. We add 56 and 34 together, so. Okay, any questions with the word complementary? Like how you could use it? It's just like the problems we just did, 9, 10 to 39, 40. You still, but now, the big thing is complementary can be that weird situation where the angles are separate. Now they're drawn like this. They're not even touching each other. Maybe they don't even look right, but they still add to make 90. These are still considered to be complementary, even though they're not adjacent to each other. Now that seems a little goofy, but they're not even close. But you can still add that number to 90. That's a complementary. Okay, now, the reason why I bring this up and why I want to talk about it, and there's this one particular symbol that your book is going to use. And I'm going to use this picture to help me out with it. This is the symbol I want you to know, and I want you to put this part in your notes. DE, that ray. Okay, now which way does the ray face? Towards D. Okay, DE, that ray. Here's the symbol I want you to write down. It's an upside down capital T. Okay? And then EG. This is the main thing I want you to write down right here. And I want to get us to know, like, what is that telling you? Because you're going to see the symbol a lot in your book. Okay, so looking at this and looking at the picture, what can you piece together? What is this telling you from that picture? This stick and that stick. What do you think the symbol stands for? By looking at the picture and looking at those two symbols. What, say it again? They're adjacent. I agree, they are adjacent, and there's one more thing. They're adjacent for touching, but what about the two pieces? What are they forming? What type of angle is that? 90. This symbol literally means perpendicular. That's the symbol they're going to use from now on. So this is saying ray, this is how I would say it out loud, ray DE is perpendicular to ray EG. That's how I would say it out loud. I'm going to put that in air quotes because that's how you pronounce that. So this is the perpendicular symbol. And that's just a big fancy word for 90 degrees. That's what you need to realize. They can be any objects. Any geometric figure can be perpendicular. Rays, segments, lines, planes, they can be perpendicular to each other. It's like my planes here, this wall and this wall. They are perpendicular to each other right in the corner, 90 degrees. The floor and the wall are perpendicular to each other, the flush, right? That's the symbol we use, a little upside down T. I want you to get to know it. Because I know some people will see that in like chapter 3 and then they're going to be asking, what does that symbol mean? It is 90. That's what it means. So you can piece that together. Okay, we don't have a symbol for supplementary. We just don't. There's no weird symbol for it when they make a straight line. They just say that you have opposite rays, that type of thing. Okay, I think I covered everything except for vertical. Got to talk about vertical. Vertical. This is my last example here today. Vertical angles. Or when you have some objects that are straight across. These could be lines, they could be segments. I don't really care. They could be rays for all I care. But they're straight, and they're forming angles like this. These angles are vertical to each other. Those are vertical angles. It's actually a theorem about them. What we didn't discuss last week is that vertical angles, these two angles, they're exactly the same. They have to be the same number. Now, I'll tell you why. I want to explain, why do I know that those two angles are exactly the same angle when you have straight lines like that? And that's what I want to discuss right now. Here's why, and it actually comes to the thing I just erased right behind it. That this angle right here, in fact, let me get rid of part of this picture. You don't need to do this, but I'm going to get rid of part of this picture. What did these two angles add up to make? 180. So let's say that this angle is 20 degrees. Let's just say that. So this angle over here would have to be what? 160, right? Because it makes a straight line. Does that make sense? They add up to be 180. Well, when I made this straight line here, like this angle here has to be the same as the other one. The reason why, let me get rid of this line. What did these two have to add up to make? Yeah, because it's a straight line, right? So this is forced to be 20. It's forced to be because this is literally a straight line. So this would have to be 20, just like the other one. It would have to be 20 because the way that the straight lines work, that they have to add to be 180. So it forces vertical angles to be the exact same number because of the word supplementary. Okay? Perfect timing. Okay, no homework today. If you have not turned in page 41, some point today, just make sure name, period number, dates on there, the page numbers are on there. You can turn at any point today on here. Okay? Make sense? Alright, did that help you out a little bit today with that homework?
Yep.
Okay, good. Ooh. You're on the struggle. Struggle is real.
anxious speaker.
No, I literally come from like the other hallway, so it's not like I'm a door down.
You know that hand motion that I always make? He just did it as soon as he was like,
That's gotta feel good.
Yeah.
I was like, shit, not at my